Question 12. We are given a diagram that shows a curve with equation 4x to the 1/2 minus 2x for x greater than or equals to 0, and a straight line with equation y equals 3 minus x. The curve crosses the x-axis at this point A with coordinates 4, 0, and crosses the straight line at B and C. Part A, find the x coordinates of points B and point C. When the curve intersects the line, they share the same y coordinates, so we equate the equation of the curve and the equation of the line. The curve has equation 4x to the 1/2 minus 2x, and the line has equation 3 minus x. So when we rearrange 4x squared is 3 minus x plus 2x, move the negative 2x over, so that 4x to the 1/2 is 3 plus x. In order to solve for x, we can square both sides. When we square the left side, we have 16x. And when we square the right side, we have the square of 3 plus x. So that 16x is 9 plus 6x plus x squared. Rearranging, we have x squared plus 6x minus 16x plus 9 equals 0. X squared minus 10x plus 9 is 0. X squared minus 10x plus 9 equals 0. That can be factored to be x minus 9, x minus 1 equals 0. So x is either 9 or x is 1. That will give us the x coordinates of B or C, so that we know that point B has x coordinates 1 and point C has x coordinates 9. B is to the left of C. Part B, show that B is a stationary point on the curve. If B is a stationary point, then dy dx at x equals 1 must be 0. Y is 4x to the 1/2 minus 2x. So we find dy dx for the curve, and that will give us 4 1 over 2x to the negative 1/2 minus 2, so that dy dx is 2x to the negative 1/2 minus 2, and we can write this as 2 over square root x minus 2. At B, the x coordinate is 1, so we evaluate dy dx at x equals 1. That is 2 over square root 1 minus 2, which is 2 minus 2 and 0. Therefore, we say that B is a stationary point on the curve. Part C, we need to find the area of the shaded region. So to find the area of the shaded region, let's look at this. If you integrate with respect to y, it will solve all your problems. That is not going to help here. What we could do is use that. So what we could do is we can form a triangle here. So that will give us a triangle. And then we take the area of the triangle minus this area. Let's say this area is given by A1. The area that we need to find is given by A here. So this area A is the area of the triangle that we have with one vertex C minus the area of A1. That is what we need to find. Let's find the area of the triangle. To find the area of the triangle, we have half times base times height. This is the base. The x-coordinates of C is 9, and then the x-coordinates on this line. This line crosses the x-axis at the point 3. So the base of the triangle has a length of 9 minus 3. And the height of the triangle, we need to find the coordinates of C to find the height of the triangle. So this C has x coordinates 9. So we need to find the y coordinates now. The y coordinates is y equals 3 minus x minus 9. So we have y equals 6. The y coordinates of, negative 6 here. The y coordinates of C is negative 6. Then the height of this triangle is given by 6. The area of the triangle is 18 square units. That gives us the area of the triangle. We need to find the area A1 here. The area A1 is the area between the curve and the x-axis. So x is from 4 through 9. To find the area A1, we integrate the curve 4x to the 1/2 minus 2x with respect to x from A, which is 4 until 9. So we have 4 until 9. But the area is in between the curve and the x-axis. It is below the x-axis. You must have a negative here. It's easier if you just multiply the negative in. So you integrate from 4 to 9. When you multiply the negative in, we have 2x minus 4x to the 1/2. And we need to integrate this with respect to x. Upon integration, when we integrate 2x, we have 2x squared over 2, which is x squared. And then that would give us x to the 1/2 plus 1. You have x to the 3 over 2. Then you must divide by 3 over 2. And we need to evaluate from 4 to 9. That gives us x squared. And this part is 8 over 3, x to the 3 over 2. We need to evaluate from 4 to 9. So this area A1, replace x with 9. That will give us 9 squared, which is 81, minus 8 over 3. And then we have 9 to the 3 over 2. Minus, now we replace x with 4. 4 squared is 16, minus 8 over 3. 4 to the 3 over 2. So that is 81 minus 8 over 3, that is 27. So minus 16. The 2 negative will give us a positive. 2 to the 3, that will give us an 8. And finally, this is 43 over 3 square units. The area that we need to find, the shaded area, this is the area of the triangle minus the area A1. Area of the triangle is 18 minus 43 over 3. So we have a value of 11/3 square units. That is the answer that we want.